start the recording. All right, let me pull the chat up so I have that available. Okay. All right, well, it's 1 o'clock. Looks like most everybody's logged on, so we're going to go ahead and get started. Welcome to Statics. My name is Dr. Michelson, and I'm going to be your instructor this semester. I want to welcome everybody to Statics. This is my first time teaching Statics, and I'm really excited to teach it. I'm really excited to have everybody here in class. Today's content is really just a big housekeeping session, just going through some various aspects of how we operate the class and how we're going to do things. First thing I want to do, since it's for many of you, it's your first time logging on today. I want to go through the attendance roster. I'm not going to do this during every lecture, but I want to make sure that everybody's here and that you're able to hear me and see me, as well as the announcement slide. So I'm going to go through one at a time. And if you want, you could either respond in the chat or respond using your microphone. Either one is fine. But I'm going to go through the roster and make sure everybody can hear me and understand me. So let's start off with Mr. Adams. Awesome. All right. Mr. Armbruster. All right. Mr. Ashworth. Awesome. Mr. Ball. Mr. Bishop. There we go. Ms. Bogus. Mr. Brown. Miss Chapman. All right. Miss Cockeram. Did I pronounce that correctly?
You were good on pronouncing it.
Okay. Thank you. Mr. Dara. Mr. Davis. Mr. Douglas. Let's see if he's on. Okay, I don't see him in the logs. We'll move past him. Mr. Evans.
Here.
Awesome. Mr. Fishbaugh. Mr. Garrison. All right. Mr. Hale, or Alex Hale. Yep. All right. Mr. Krantz. Mr. Littman. I don't see him in the chat. Ms. McDaniel. I saw an email from you, but it just came in. I'll get to that here in a sec after we get done with class today. Mr. Moore. Awesome. All right, Mr. Morris. All right, Mr. Page. Mr. Sawyers. Mr. Tucker. Mr. Wetzel. And Mr. Whitehead. All right. Is there anybody's name I didn't call? All right. Okay, we'll go ahead and proceed. Let let me go through just real quick. I wanted to give everybody my office hours. My office hours are Monday through Wednesday from 2 to 4, so right after class today, and then Tuesday, Thursday from 10 to noon. And we'll talk about how to access that through Microsoft Teams and whatnot here in a bit. But I just wanted to mention that now. My main goal for today, I want to go through the course operation, the technology and the tools that we're going to use throughout the semester, and then go into the syllabus, the course overview, the organization, and a little bit of background on statics if we have time. I always like to answer during the first lecture just why the heck you're even in this class, because if you're going to spend your time and your energy and your money enrolling for a class, I want you to understand why you're doing it and how it fits into the big picture. So let's get right into it. But first off, before we start, getting into the meat of the discussion, I'm not sure if you all have had me for class. You might have had me for Engineering 103, but that's for those of you that had that, it's a big sea of faces, and I'm not sure if you all know who I am. So I wanted to just briefly introduce myself. So I'm an associate professor in the Department of Civil Engineering. And the vast majority of you all are civil engineers, so you're going to get to know me pretty well over the next couple years. I'm, in the engineering building, second floor, last office on the left. So, hopefully when all this coronavirus stuff starts to settle down, you all can stop and see me at the office. A little bit on my educational background. I was born and raised in West Virginia. I've lived here all my life. I did my PhD at WVU and then came here, and I've been here ever since. I am a licensed professional engineer. I'm licensed to practice in West Virginia, and I'm a civil engineer, but my real area of expertise is in structural engineering, and particularly steel and in bridges. And so this is definitely sort of a bucket list class for me. I'm really excited to teach it. Also, more important than all of that is my family. On the bottom right, that's my wife Becky, and on the top right, that's our daughter Stephanie. She is, in fact, a sweetheart, as it says on her shirt. That is an immutable fact. I can testify to that. Like I said, my background's in steel design, and particularly in highway bridges, and I've been doing research on that for the past 10 years or so. One of the research projects that's really taken up a lot of my time has been the development of a press brake form tug girder. It's basically you take a large structural plate that you get directly from the mill and you bend it into a U-shaped section for use in short span bridges, and it's gotten the attention of the industry. It's really been an exciting project to be involved in. I've been involved in a number of installations in Iowa and Ohio. We've had 2 installed in West Virginia. And so I'll do a lot of not just field work on these projects, but also a lot of computational modeling. And it's funny, a lot of the computational models that I use, they're all built upon the principles that we discussed in this class. So it all sort of comes full circle. I'm also a pretty active guy on campus. I'm the advisor for the SAME ASC student chapter as well as Theta Tau. I'm a previous president of the West Virginia section of ASCE, and I'm also the current faculty advisory chair, or the chair of the faculty advisory committee for students with disabilities. I'm really excited to teach the class. I'm really excited to have everybody on board, and with that, I guess we'll go ahead and just get right into, I guess, the meat of discussion with the class. Since this is a virtual course, I want to start off by talking about some of the technology that we're going to be using during the semester. Obviously, we're going to be using Blackboard and Blackboard Collaborate. Everybody here is on that now. So Blackboard is going to be how we meet as a class together, but there's a lot more that we're going to do via Blackboard. I'm going to post grades on Blackboard. I'm going to be posting all of the lecture notes, the homework assignments, homework solutions on Blackboard. We're going to conduct our exams via Blackboard. So Blackboard is going to be the primary tool that we use to conduct class. So you're definitely going to want to be checking Blackboard regularly. I would say at least daily. Now, in this course, as well as many courses in engineering, you're going to be doing, a fair amount of homework. And typically, what you'll do is if let's say I give you a homework assignment, you break out your quad paper or your engineering paper or what have you, and you're doing the assignment, and then you have a hard copy assignment, to actually get it to me, because we're in a virtual course, you need to scan that assignment and then send it to me. And if you have a printer or scanner combo in your apartment or your house, that's fine. But if you don't, I highly recommend using Cam Scanner. First off, Cam Scanner is free. It's available for both Apple and Android. And if you sign up with your EDU email address, when you create a Cam Scanner account, make sure you use your EDU email address, because you get some features that you don't get with just a traditional mailing address. You get extra storage space on your Cam Scanner account, and there's a watermark that gets removed, gives you a little bit more space on the page. So I definitely recommend that you download that. I sent everybody a link a few days ago with it. I actually walked you through how to use Cam Scanner to take an assignment and upload it to Blackboard. And so you're going to be doing that a fair amount throughout the semester. So you probably want to watch that and make sure that you're comfortable with doing that throughout the semester. The next tool I want to mention is Microsoft Teams. We're going to be using Microsoft Teams for a couple of different things. First, we're going to be using it as a means to do one-on-one meetings. So if I assign a homework assignment and you have questions, you're having trouble with it, and you're a little unsure where to go, you can meet me via Microsoft Teams. If you first off, on your laptops or on your personal devices, you probably already have Teams installed. If you have Microsoft Office installed, the Office 365 package, you should already have Teams installed. If not, I mean, it's an easy download from Microsoft. When you log in, make sure you use your Marshall credentials, your Marshall ID. If you log in, you should already see a channel created for Engineering 213. I'll use that channel periodically throughout the semester to send some informal updates to the class. For example, I might say, hey, homework 2.2 has been graded, and so you can go and log in. And I'll just, instead of bombarding your email inbox, I can just do it through Teams. It's a lot easier for everyone involved. But if you have questions on homework assignments, we can use Teams to have not just a phone call. We can do a video call. We can do screen sharing. I could pull up and we could start working on the problem together on the board. So there's a couple of different ways that we can interact with Teams. Another feature in Teams, which is actually pretty slick, that I'm going to try and use this semester, is the class notebook feature. So, for instance, in this class, let's say we have a 50-minute lecture. We'll start off the first few minutes, recapping, doing some lecture, and then we'll be doing some example problems in class. Well, what I can do is I can do those problems on the screen. I've got a smart pen and I can do them on the screen, and I'll do them through that notebook. You all can actually access that notebook outside of class. So it would be as if everything that I did on the board was accessible through Teams. And so we're going to try that out this semester. I think you'll find it will make your life a lot easier in terms of taking notes and whatnot, because if let's say we're doing a problem and you miss something, don't worry. Literally everything that was on the board will be in your notebook through Teams. Finally, Teams is also going to serve as a backup in case for some reason we have issues with Blackboard one day. There were a couple instances last semester where Blackboard crashed on us. I don't think that there's as much of a chance that's going to happen this semester as it did last semester. Last semester, everybody went online and it was sudden and it was all at once. This semester, the universities had a bit more time to plan, so I don't think that there's as big of a chance that that's going to happen, but it might, and so always have a plan B. Also, just make sure that everybody that you have a browser, either Chrome or Firefox installed. That tends to work the best with Collaborate. I'm using Firefox right now and it's working beautifully. Microsoft Office, you should have that installed. If not, I imagine most of you already do. And make sure you have Adobe Reader installed because you'll be accessing a lot of PDFs. That's pretty much it for the software component. Before we get into the course overview, I want to take a second and see if anybody has any questions. I'm the easiest guy in the world to get along with in terms of questions. If you have questions, you can use the raise hand feature on Blackboard. You can just use your microphone and say, whoa, Dr. Mike, you're doing that problem. I have no idea what's going on. Please, stop me and we'll go through this together. But does anybody have any questions before we move forward? All right, we'll go ahead and keep on trucking. Let's look at the grade breakdown for the class. I'm going to grab this over here. So first off, let's talk about the grades. So I am going to count attendance in the course this semester, and because this class is so important to what it means to be an engineer, I want everybody to be engaged and attentive. So I'm going to count attendance for the grade, and I'll show you how I'm going to count attendance here in a bit. We are going to have a fair amount of homework in this course, and really with statics, the only way that you learn statics is to do it. And so I'm a big proponent of the homework. I think the homework is arguably one of the most important aspects of the course. The homework's going to be worth 30%, and we're going to have 4 exams throughout the semester, 3 of them during the semester, and 1 of them during finals week, and they're each going to be worth 15%. So they have enough of weight that they matter, but any one exam isn't going to mean the difference between an A and an F. So the idea is to, I guess, like diversify the grade breakdown so that no one component is super critical, I guess, except for the homework, because that's pretty important. Let's talk about the textbook. So the textbook for this semester is Vector Mechanics for Engineers by Beer and Johnston. What you see here on the screen is the combo book for statics and dynamics. Like myself, I'm actually only just using the statics one, but that's all we'll really need for this semester. I do recommend that you get this book solely for the fact that this textbook is used not just for Engineering 213, but for Engineering 214 as well. So it's one book for 2 different courses. And as far as I know, Dr. Bienick will continue to use this book next semester as well for Engineering 214. On top of just a really excellent resource, this statics and dynamics textbook is considered like the seminal work in statics and dynamics. It's arguably one of the best textbooks that there is. I like the textbook, and I think it's a good purchase. Whether you get a physical copy of the book or you rent the book or what have you is totally up to you. I'm not one who's going to try and make you do that. You can do this however you would like. There's a question about the edition, and that was actually going to be my next comment. Let's talk about the edition. So here's my general philosophy on the textbook edition. Most of the homework that I'm going to assign this semester is going to come from the book. As long as you're able to complete the homework, I actually don't really care which edition that you get. And so what I'm getting at is if you and a friend want to get together and buy a book together, or rent a book together, however you want to do that. If you want to borrow an old book, something, that's fine. As long as you're able to get the homework done, I don't care which book you get, or if you don't get a book at all. I do think you should get a book, but really my rule is if you're able to get the homework done, that's all I care about. The first few lectures, the homework will probably just be custom made by me because it's a lot of review of physics and units and stuff like that. And then after the first week, it's really going to be, this is what's coming out of the book. Any other questions? And did that answer your question, Mr. Page? Again, please don't hesitate to ask questions. That's what we're here for. I always said that during class. When we were meeting in person, I said, don't hesitate to ask questions, because I could just go to the janitor's closet and lecture by myself. But that doesn't really have any value, because what matters is you getting out of this. Now I'm sitting here in my office by myself talking to myself, so maybe I shouldn't have said that so much. So let's talk about attendance. So the attendance, what I'm going to do for the attendance is I'm actually going to use the log that's recorded by Blackboard. So with every session that you attend, Blackboard records who attended and how long you were in attendance. So make sure that you're on time and make sure that you stay for all of the lectures. So if you log in for 3 minutes and you log off, like it'll be pretty easy to tell. But I want to be absolutely clear. I am the easiest guy in the world to get along with in terms of if you're having technical issues with Blackboard. I know that there were some instances last semester where I had students who, lived down the holler and had issues log on time. And so I get that. And if you're having any technical issues, let me know. I don't want to penalize you for that. I am going to record the lectures. This lecture is recording right now. And what I want to do is record those lectures and post them to a YouTube playlist for the class. So I'm recording the screen capture along with the sound. Now, it might take me a little bit to, once the recording's done, Blackboard has to process it, and then I have to download it. Did somebody draw on the screen? I'm curious. Hold on, I don't mean to interrupt. Did somebody draw on? Yeah, just email me if you have Wi-Fi trouble. I'm curious. Did somebody draw, or did anybody see that, or was that just on my end? Because I saw a bunch of squiggles on the screen. Okay. Let me say this. I actually don't have a problem. I don't have a problem if during lecture, because yeah, it's off now. If oh, no, it's fine. I actually didn't know that myself. But let me say this, Mr. Adams, that's actually not a problem because we're going to be doing problems throughout the semester. We're going to be working on homework problems and whatnot. And if you need to point to something and say, "Hey, I don't understand this," that's completely fine. That's okay. It's good. It's good to know that. But no, don't worry about it. You're good. Really, you're fine. One thing I'll say about the lectures, though, it might take a little bit for those lectures. Blackboard has to process them, and then I have to download them and upload them. But again, my goal is to upload those to YouTube. You should be able to access those lectures in Blackboard Collaborate as well, or those recordings, I should say. And I'm also, like I said, I'm going to post the notes. The recordings will be available. I'm going to post the homework assignments and the solutions, all of that. So I guess if you have technical issues and you miss the lecture, that's completely fine. But I am still going to hold you to the work, to the homework assignments and things like that. So just be sure and be aware of that. Let's talk about homework. So with this course, I think what makes sense, especially with the fact that we're moving to a virtual delivery, is to have pretty frequent homework. And so the model that I'm going to employ is basically going to be that you have a homework assignment sort of every lecture. So for instance, this is a Monday, Wednesday, Friday class. I don't have any homework today. It's just housekeeping. But let's say that, okay, we meet Wednesday. So Wednesday, we're going to talk about a specific topic. And then I'll give you an assignment on Wednesday, and it will be due Friday. Now, I want to be clear. I'm not trying to give you hours and hours of homework every week. I mean, the homeworks, for instance, this homework on Wednesday will probably take you about 10 to 15 minutes. It's not intended to be super work intensive. The idea is to keep you engaged and to give you, or make sure that you have some skin in the game in terms of what we're working on throughout the semester. So, for example, we have a lecture on Wednesday. We have a homework about that lecture. It's due Friday, and we just make sure that we're engaged and active. In terms of the homework format, I'd like you to use either quad paper or just blank, like copier paper like this. And the reason why is because those two show up pretty well when you use Cam Scanner, because you have to have some contrast. If you're using like a darker paper and the ink is, or if you're using a pencil and you write kind of lightly and the paper's dark, sometimes it doesn't show up very well. So that's why, if the paper's really light and the ink or the pencil's really dark, then the scan comes through a lot more clearly. Make sure that your handwriting is neat. Make sure that you're using a straight edge and statics. A lot of the homework assignments that we do in our involve figures, so make sure that you're doing that. Question on the graph was, what is quad paper? Give me 1 second, I can show it. But basically what I'm talking about is engineering paper. So you've probably seen this before. Let me put it up to the camera. If you click on the camera on the bottom left, it sort of, instead of focusing slides, it focuses on the camera. This is engineering paper or quad paper. Basically, the way it works is that the front looks blank, the back has a graph printed on it. You only write on the front because when you scan it, the graph doesn't show, but it's easy to see the lines. It's a pretty traditional thing that engineering students use. I'm not going to make you purchase it for statics. It can be a little expensive. It's good to have some though, because we're operating virtually. If you just use like white copier paper or something like that, that's fine. But hopefully next semester or next year, when we're back to being in person, you might need to do that. Yeah, quad paper is just sort of like shorthand for that. One other thing on homework, because I'm assigning homework so frequently, I have a late homework policy, but I don't really think it's going to matter all that much because what'll probably happen is, so we have class, Monday, Tuesday, Wednesday, Thursday, or we have class Monday, Wednesday, Friday. So let's say you turn a homework assignment in on Monday. I'll probably grade it either that evening or Tuesday to get it back to you before class on Wednesday. And when I grade it, I'm going to give you the solution as well. So we'll sort of be at a point where it's like, if you were to turn in that late homework, you'd already have the solution. So if you're able to turn in late homework, it'll probably be a 20% penalty just based on the timing, because I have it like 20% per day. But I won't accept it after it's graded and returned. But here's the thing. I don't really think that's going to be too big of a deal. When we went online in the spring, I switched up my model for all my classes. Usually in my classes, what I would have is a small number of really, really big assignments. So for instance, in steel design, I might only have 9 homework assignments throughout the entire semester, but they're really, really big. Once we went online, I said, I don't want to do that. To make sure that everybody's engaged, we're going to have a homework assignment every lecture. And what happened as a result is, not only did the students actually like it, they actually preferred that, but if you missed one assignment, it ended up being not that big of a deal because there were so many more of them. And so I'm hoping that sort of happens here as well. Again, if something happens, if you're having technical issues or any other thing comes up where you're not able to turn in, let me know. I'm the easiest guy in the world to work with, but the big thing is to let me know. If I don't know, then I don't know. I mean, again, I'm talking to a little box in my office. I want to make sure that I'm interacting with you if you have any concerns throughout the semester. Finally, I want to talk about the exams. So I wrestled a bit with how to do exams in here and how many I wanted to do, and I ended up settling with 4 exams. I'm a big proponent, at least with the in-course exams, that they not be comprehensive. So there's 3 exams that are going to be during the semester, and the 4th exam is going to be during finals week. Those exams that are during the semester, I did not want them to be comprehensive. And if you look at the topics that we cover in statics, it really sort of made sense to do 3 exams during the semester. Those exams are not intended to be comprehensive, but some of the material does it can bleed over from exam to exam. This isn't like a history class where you can have exam 1 is up to 1800 and then exam 2 is 1800 to 1850. It's really easy to say those exams aren't comprehensive because you're only going to cover those events. But in some of these courses, the material kind of bleeds over. I'm not intending for that to happen during the in-class exams, but that can happen. The 4th and final exam, though, is going to be comprehensive. And I think that as we progress throughout the semester, you'll kind of understand why the final kind of needs to be this culminative, final assessment of everything in the course. One thing, though, I want to be absolutely clear on, I am not a time crunch exam creator. I'm not a fan of creating a 6-hour exam and only giving you 50 minutes to do it. I've never been a fan of that. And so I always create my exams so that they're not time critical. One of the things I tend to use is the rule of three. So what that means is that's just sort of a simple way of ensuring that they're able to be done on time. So for instance, if you have an exam that's an hour-long exam, then I need to be able to do it in 20 minutes or less. So I cut the time in three, and I actually do the exam and I time myself. And if I can't do it in 20 minutes, or if I need more time, then I will cut material out of that exam to ensure that if I can, that I can do it in 20 minutes or less, so that you can do it within an hour. And that's worked out pretty well with me so far, and I've never really had too many students, think that my exams were too long, and I'm not really a fan of that. I want you all to succeed as much as possible. Okay, I want to pull up the syllabus real quick and show you some different things in the syllabus, and then I want to open it up to questions before we talk about what's going on in statics and what we're doing in here. So let me go to the syllabus. Okay, so first off, both of these, just the presentation and the syllabus, are uploaded on Blackboard, so everybody in here has access to that. I want you to just look through this at your own pace. We've got all the info here on when we're meeting, Microsoft Teams, all that, course description, all that, the grade basis, percentages and whatnot. I have here just a list on page 2. This is a series of, so there's the communication policy, which I've already talked about that, Blackboard and emails and Microsoft Teams. Just make sure that you're up to date on all of that. There's a list of all of the software packages that we're going to use, and if you ever have any questions, you can either contact me or contact the help desk if Blackboard's giving you any grief and whatnot. So I'll move past that. We've talked about the attendance policy, the academic dishonesty policy. Look, I'll say this: I don't really think that this class is one of the more difficult courses, depending upon how you approach it. It is a math-heavy course. I'll go ahead and tell you that now, that we're going to be doing a lot of math in here, but it's not incredibly difficult. And because it's so important. Again, look, I'm an easy guy to get along with. I think I'm a pretty fair grader and fair assessor. Just give me your all, give me your honest efforts, and I think we're going to do just fine. Let's see. I'll move past ABET outcomes and all that. You all can review that on your own. I put this in my syllabus, and I'm wagering that just about every professor at Marshall's putting this in their syllabus. Now, this is a virtual course, so we're obviously not meeting in person, but this is just some info that everybody's going to want to follow. Just making sure that you're wearing your masks if you're on campus, and that you're practicing proper hygiene and whatnot. Even if this doesn't pertain to statics, just make sure that everybody's being safe. And if you haven't signed your return to campus agreement, make sure that you do that. Most people I looked had already done that, but just make sure that you have. Okay, this is really what I wanted to focus on, and this is the schedule for the class. What I'll go ahead and tell you is that while we might, first off, this is a tentative schedule, so we might hop around with topics here and there, but one thing I will say is that while we may dance around with some of the lecture topics here and there, like they may carry over from day to day, the exam dates are pretty much going to remain unchanged. These are when I'm going to do the exam. So the first exam is going to be Wednesday, September 23rd. And I'll tell you a little bit about how we do exams in class. If you notice, the exam is on Wednesday, but Monday is a review day. And here's how I do review days. What we'll do is we'll come in, and I will, at the beginning of lecture, tell you, okay, here's the format of the exam. Here is what what the exam's going to cover. Here's the stuff that you need to review, so on and so forth. And then I do that for about 5 or 10 minutes, and then I kind of shut up and let the entirety of the class ask whatever you want. We can talk about types of questions that'll be on the exam. If you want to go through homework assignments, want to go back to the lectures and and say, oh, I didn't understand this example. Could you redo it? Anything sort of on the table. But the point is that that sort of puts a little bit of onus on you. So, for instance, if we're having an exam review on Monday, September 21st, come to class ready with questions. Go through the material, go through the topics, and so on and so forth. Our first exam will be Wednesday, September 23rd. Second exam, Wednesday, October 21st. I tend to do my exams on Wednesday so that Monday we can review, Wednesday we have the exam, and then Friday we can kind of decompress a bit so that it's not the end of the week that you have the exam. We can decompress, cover something, and y'all can have your weekend off. Third exam will be November the 11th, and then Friday of finals week is our slot for the exam. So that's the timing. Again, I don't think the exam dates will change too much, but I'll make sure and keep you posted. Before we get into why we're here and what we're doing in statics, I want to pause and see if anybody has any questions about the course operation, how we're going to grade things, any of that. The floor is yours. All right, I'm not seeing anything in the chat, so we're going to go back to the notes. And again, if you think of something, you can ask. I mean, you're not going to hurt my feelings, please. I want to make sure that I'm answering all your questions. Okay. So let's talk about this class. Let's talk about statics, and let's talk about why you're even taking this class. It's funny, and this is an interesting experiment that you might want to try if you have any. I don't know. Hold on. There's a question in the chat. Oh, give me a sec. You mentioned review of physics. I'm taking physics now. Will this cause any issues? No, it really won't. That's a great question. When I say a review of physics, so we're going to talk about that physics on Wednesday. What I'll say is this. First off, really the only thing that I want to make sure that everybody's comfortable with right now is some fundamentally basic unit conversion stuff. Just making sure you can convert inches to feet or inches to meters or stuff like that, and we'll go through together and have some exercises together. But you don't really need everything physics right now. We're going to be operating off of some very, very base principles in physics, and then taking that, in our own direction moving forward. So you don't really need physics to succeed in this class. That's completely fine. What I'll say is this: it doesn't hurt to have physics beforehand. But it's not going to hurt you if you haven't. You're going to be fine, I promise. What is much more critical, I would say, is the math. That making sure that you're good with trig, that you're good with algebra. Yes, there will be a little bit of calculus in here, but the algebra and the trig is much more critical. Any other? And did I answer your question? Good deal. All right. So talking a little bit about statics, and this is a really interesting exercise that you should ask, or you should try, if any of you have any family members, maybe some parents or an older sibling that is a practicing engineer. And by practicing engineer, I mean somebody that designs stuff. If they're a civil engineer and they're designing, buildings or bridges or dams, or if they're a mechanical engineer and they're designing, engines or gear systems or anything like that. There's an interesting experiment that you should try. And there's a couple of questions that you can ask a practicing engineer. And first question you could ask him is, well, how important is statics? Or, maybe another way of asking it is, what was the most important class that you took as an engineer, that related to design? And just about all of them will probably say that statics is one of the most important classes that you'll take as an engineer. Or they'll rank it pretty highly. But then on the flip side, ask them, well, how many statics problems do you do a day? And they'll laugh and they'll say, oh God, I don't do any. they'll laugh at you. The overall point I'm making is that some of the problems that we do in here do seem a little, I don't want to say hokey, but we'll have problems where there'll be a barge that's being towed by 4 cables, and 2 of the cables have a tension of 200 kips and 300 kips respectively. What's the tension on the other 2 if this one's at 15 degrees and this one's at 70 degrees? We're going to have problems that are kind of like that. And the reason why we do this stuff and the reason why it's so important is because of the third question. Most engineers will tell you that statics is one of the most important classes that they ever took. Now, while they might not be doing many of these problems every day, if you ask them the third question, which is, well, does statics play a role in what you do? Do you use these principles when designing buildings and bridges? Every one of them will say yes. While you might not be, doing some of these theoretical problems that we do in this class, you are going to use this stuff throughout your career. All right, I'm a licensed engineer. I've been, doing this work for, close to 10 years, and I use statics every day in every one of my designs and my projects that I work on. And any engineer who does any type of design will say the same thing. This stuff is fundamentally critical to design because it really opens the door into developing the tools that you need to design. For example, I'm here on the 2nd floor of the engineering building, and I'm standing on a floor system. Okay, well, the principles of statics will tell me as the engineer what are the forces and the response of the floor beams that are keeping this system up. I use the principle of statics to determine those forces, and then as a designer, I then ask, well, how deep does this beam need to be? How many beams do I need to use in order to safely support these loads? And it all starts with statics. And so I'm really excited about this topic. I'm really excited about this science, and I'm happy to share it with you. But maybe one of the things I kind of need to do is actually define just what the heck statics even is. Okay, so we're going to go back to square one, and I know we've mentioned physics. Well, square one for this science is talking about physics. So what is physics? And that is the first off, if you ask that question, you can go to the dictionary or Google or Wikipedia or whatnot, and you get this definition that's about yay big. But if you want a short and sweet, tiny definition for what is physics, for those of you that haven't had it yet, or maybe those of you that are in it now, maybe the professors on the other side of 3rd Avenue, maybe they'll agree with this definition, maybe they'll not. But my sort of short and sweet definition for physics is that it's the study of matter, and I have a grammatical error I need to fix there. It's the study of matter, energy, and the interaction between them. If you want a short and sweet definition for what physics is, that's physics. Just matter, energy, and their interaction. Now, physics is a really big field. There are all sorts of different sub-disciplines of physics. You've got, quantum mechanics, you've got solid state physics, you've got electricity and magnetism, particle physics, there's condensed matter, there's all sorts of, these sub-disciplines of statics. And one of the traditionally, the first discipline of statics that most students are introduced to is mechanics. So mechanics is one of the primary, I don't want to say primary, I guess primary is the best term, primary disciplines within physics. And so what is mechanics? Mechanics is the branch of physics that deals with bodies under the action of forces. So I have this book, I take this book and I apply a force to it. What is its response? That's mechanics, okay? And so there was a question about, you mentioned a review of physics. Well, what I would say is this. Physics is a super broad, super big field, and all we care about in this course is mechanics, which is such a tiny sub-discipline within the field of physics, but for us, mechanics is everything. And so we're going to take mechanics and explore it in a super, super big fashion. And don't worry, there's really not a whole lot that you needed from physics to get in here, because that's what we're covering in here. Now we're going to build off some basic concepts, but that's really where we're at. Now, let's talk about mechanics. So in mechanics, when you're studying mechanics, you really need to categorize it. You need to categorize two different areas, okay? The first that you need to categorize is what is the media that you're looking at, okay? So remember, mechanics is the study of bodies under the action of forces, under forces. So the first thing we need to look at is what is the body? What is the media? What are we applying load to? And so we could categorize this in a number of different ways, but really it's sort of, when you start divvying it up, it goes to three different areas. Whether or not we're looking at rigid bodies, whether we're looking at deformable bodies, or whether we're looking at fluids, okay? So a rigid body would be a body that's assumed not to deform under the load. So for instance, I have here this beam mock-up in my hand. I take this beam and I apply load to it. I take this beam and I bend it. You know, this obviously deforms. I'm taking it and I'm bending it, okay? And so that would be looking at a deformable body. Whereas a rigid body, I apply that force and I assume that it doesn't deform. Now, to be fair, nothing in this world is perfectly rigid. Everything deforms, you know, to some extent. But for the purposes of categorizing its response, sometimes not only is it easier to ignore that deformation, but it also doesn't matter. So for instance, if I have this beam and let's say I put 20 pounds right in the middle of the beam and I'm supporting it on either end, whether I characterize it as a deformable body or not, if I have 20 pounds in the middle and everything's symmetric, each hand has to hold up 10 pounds. And that determination is a principle of statics. You know, the idea is that 20 pounds is in the middle, so 10 pounds on each end keeps it in equilibrium. That is a statics problem right there. Now, just as important as the media being studied, whether it's a rigid problem, a dynamic problem, or a rigid problem, a deformable problem, or a problem involving fluids, the other thing that we need to categorize is the condition of the situation. And so we really define that into two areas. That's statics and dynamics. So, you know, you're in Engineering 213, this is statics. Engineering 214 is dynamics. What's the difference? Well, statics deals with bodies that are at rest or not moving, or if they are moving, they're at a constant velocity. But really, for the purposes of this, the vast majority of our problems are going to be motionless. They're going to be sitting still. Dynamics deals with bodies that are moving and specifically accelerating. Now I'm a civil engineer, so statics is going to be much more important to us as civil engineers because hopefully our buildings and bridges don't really move too much. Hopefully they sit still. But you do need to understand both for what you're doing in your degree. This is a table that I put together that really kind of breaks down what's going on with this field of study. Mechanics is a field that you're going to assess in multiple different venues. So for instance, right now you're in Engineering 213, and in this course we focus on rigid body statics. We don't consider deformable bodies in here because after you take statics, one of the next courses that you'll take is Engineering 216. The title of Engineering 216 is Mechanics of Deformable Bodies. That's the whole point, is that the idea is, you know, we've considered rigid body statics in Engineering 213, and Engineering 216 will consider deformable body statics. That science is sometimes called strength of materials or mechanics of materials. So if you ever hear that term, strength of materials or mechanics of materials, that's what it's talking about, deformable bodies. And so rigid body statics is what we cover in here. Deformable body statics is in 216. Fluid statics and fluid dynamics is what you cover in Engineering 318. As for dynamic situations, you'll cover rigid body dynamics in Engineering 214. Deformable body dynamics is actually a bit more of an advanced topic. For you civil engineers, you really won't deal with that until grad school because there's really only one area that we as civil engineers care about that, and that's in earthquakes because buildings vibrate when they're being subjected to an earthquake. So, and for mechanical engineers, that's a topic that you would care about as well. You might cover it a little bit in 214, but again, that's a pretty advanced topic. But that's pretty much why we're in this class. I always want to make sure that it's important that you understand what you're doing in this class, why you're in here, and what the purpose is. What we're going to do on Wednesday, and this is true of Wednesday and Friday, is we're going to cover some of the preliminaries that you need. This is stuff that you've seen in other classes, you know, like the prefixes, like what is a kilogram versus a milligram, you know, all those SI prefixes, and some of the basics of mechanics that you've seen in other classes before. And then we're also going to cover the mathematical preliminaries, making sure that everybody's good on the algebra, on the trig. Yes, we're going to have a little bit of calculus in here, but it's going to be pretty straightforward stuff. And then we're going to next week really dig into statics. And the first thing that we're going to have to assess in statics is a mathematical concept, a mathematical construct called a vector. And what a vector is, what we use vectors for, how we manipulate them, how we add them. Multiplying vectors is going to be a thing in and of itself. And so a lot of this class is going to be applying principles of statics, but also looking at this concept of a vector, which you probably haven't seen before in some of your other courses. In fact, I mean, the title of the textbook is Vector Mechanics for Engineers, because how vectors play into it is a big component. But that's really where we're going for the next couple weeks. Is we're going to look at the preliminaries, look at the mathematical prospects, and then our first main topic is going to be the statics of particles. So basically looking at the equilibrium of an object, assuming all the forces all meet at a common point. And that's what we mean by a particle. Past that, then we'll look, well, what if they don't meet at a common point? What if they're offset? And so that's sort of where we're going for the next few weeks. I know we're running out of time, but we pretty much covered everything that we needed to cover. Are there any questions before we close it off for today? Understandable. Well, I'm going to go ahead and stop the recording. Again, if anybody has any questions, they can reach out to me and send me an email or whatnot, and I'll be happy to address them. Let me go ahead and